internal voice. Okay, we will be able to continue discussing the topic of mass transfer, one of the heat transfers of transfer phenomena. Okay, transfer, not transfers. Okay, gosh. Okay, this is a problem. Okay, take a look. Very lengthy problem, right? Okay. This is Bachelor of Science in Chemical Engineering Board Examination. Okay, May 1994. Okay, so how many years passed from now? May 1994. Okay, so Monisha. Okay, I will read. Carbon dioxide is diffusing at steady state through nitrogen gas by equimolar counter diffusion in a conduit 2 meter long at 300 Kelvin and a total pressure of 1 atmosphere. Partial pressure of carbon dioxide at the left end is 20 kilopascal, at the other end is 5 kilopascal. The cross section of the cylindrical conduit having a radius of 0.025 meter at left end and tapering uniformly to a radius of 0.05 meter at the right end. Calculate the molar flow rate of carbon dioxide. The diffusivity is 5 times 10 to the negative square meter per gram. Okay. So our identification that is gonna be a mass transfer first, the diffusivity. Okay, diffusivity is 5.0 times 10 to the negative 4 meter square per gram. Okay, and then molar flow rate is another identification. So it's gonna be usually mass flow rate or molar flow rate or diffusion rate. If the problem will ask for diffusion rate, so that is more general. It could either be molar flow rate or mass flow rate. That's still under the mass flow rate. Okay, like that. And then if it will ask also the mass flux. Okay, molar flux is just the same with molar flow rate and mass flow rate. Be careful also. Okay, but before going further, I need to introduce to you again the basic formula of the flux. Flux. Okay, in transport phenomena, this flux is very important. So this is the rate of transfer over the area. So the rate of transfer general also, right? So it could either be momentum rate transfer, okay, heat rate of transfer, and mass rate of transfer. So again, there's a time for the rate, right? So it's gonna be in momentum dv dt, right? In the transfer, okay, d capital T over dt. Small t is the time, okay? And then for the mass transfer, dc dt. And then all of them each over area. And you will adjust, not really adjust, you will play around the crisscross multiplication in algebra. Okay, and you can get the value of the molar flow rate, mass flow rate, heat transfer flow, okay, heat transfer, like that, rate of heat transfer flow, rate of heat transmission, like that, okay, transport, whatever, right? But take note the word rate, always the rate, R-A-T-E, okay, because if there's no R-A-T-E, so your unit will not have time in the denominator. You get the point? So if we say mass flux, there's always time in the denominator. Okay? The same as mass flow rate. If you say molar flux, it's the same also with the molar flow rate. So there is always time in the denominator. So before solving, you need to, to detect the difference of what you are solving, so that you have an idea that that's gonna be the unit, especially if multiple choice, okay, something like that, okay? So you need to troubleshoot the units. Okay, now let's go to the first step. You need to put the what is being asked in the problem, which is the required. First, guys, we need to. Only one is being asked here. Gosh, this is the molar flow rate. Okay, only one. Molar flow rate is small letter n. Okay, so in here there are two components: carbon dioxide and nitrogen gas. Again, theory. Okay. As I told you yesterday, nitrogen gas is non-reactive. You know, non-reactive. It will never react. It's not flammable. So, meaning to say, N2 will just be steady on his location in the region. What will diffuse here is the CO2. Okay, because of the presence of oxygen, oxygen is highly reactive. So it will push the carbon in a compound, that's why CO2, to move, okay, from one region to another region, from point A to point B, from left to the right, because oxygen is very reactive, high diffusion rate, something like that. And the nitrogen will just steady there on the other end, something like that. So that's why our computation here will focus on the CO2. Do not be confused with the nitrogen. So nitrogen here is just a jargon, meaning no use in our calculation. But it is being mentioned because there are two components in there. The other one is not moving, okay? It's only on the other end, something like that, okay? Because if it is moving, then the carbon dioxide will also push back, right? So it doesn't goes like that, okay? So you get the point? So that's gonna be the theory. Because ang iyang pares man kung nitrogen gas. So if the counterpart also is not nitrogen, probably there is also a counterflow, okay, between the nitrogen and the oxygen. But in here, nitrogen is, oh my gosh, I don't have to flow like that because I am very, very stable. Okay? So, you get the point? So, meaning to say, by itself, he or she already very active and no need to react with others. Okay? Stable. Okay? You got the point? So if you are stable in chemical point of view, if you are stable, for example, I am cuprous chloride. Charot! So if I am the cuprous chloride, if I am stable already, I don't have to react with other compound. No need. Okay, why should I react to them? I have already complete charges. Okay, like this. I have complete bonding, chemical bonding, polarity or whatever properties, physical properties and chemical properties. I don't have to react with others already. So that's the reason inert, I-N-E-R-T. Okay, non-reactive. Since this is a gas, so this is noble. Noble term cannot be applied in solid and liquids. Take note also for the terminology. You will never say noble calcium. Okay? Because this term noble is applicable only in gases. Okay, so noble gas. Okay? So you got the point. You will never say noble magnesium. Okay? You can never find that in textbooks all over the world that says like that. Okay? Because noble term or an adjective noble is only to describe the behavior of a gas. Okay? But if you speak about inert, applicable to all. It could be liquid, gas, or solid. So I could say inert calcium, it's possible. Okay? But the term is not applicable to the three, is inert, but for the noble, exclusive for gas only. That's a technique. Okay? You get the point. Okay, so inert and noble is just the same, but the applicability, how to apply it, is no longer the same. Okay, it depends on the matter, 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 solid, liquid, and gas. Okay, now in here, guys, gas. So, oh my gosh, I love gases. Okay, di ba? So, if gases, what comes on your mind? It could either be non-ideal, or real gases, or ideal. There are two types only. Oh my gosh, if it is really this ideal, I can correlate the ideal gas law, bingo, something like that. So, it will be an added advantage to you because you master that formula over and over again. Okay, the most widely used gas formula all over the world is the ideal gas law equation or the general gas equation. Okay, then you correlate that also to the mass transfer. Okay, you get the point? Something like that. Okay, now, this what's being required, molar flow rate. Okay, molar flow rate. Okay, it's very useful to investigate one by one so that you can understand. Okay, I would advise you that this will be your habit, okay, to investigate one by one so that you can understand really. Do not just observe how it is being solved. You should know, oh my gosh, what's this all about? Ganon. Because if you are only dependent on how it is being solved, and then in the another problem, it will be mixed and rumbled, and then nga. Okay, because you are only memorizing the way how it is being solved. You get the point? So if you don't have this quality, more or less you will fail. You get the point? Because some, not all, it's really another type of problem. Okay, that's why you need to practice, let's say 100 problem solvings in one day like that. At least if it will come back again, then bingo. But what my point is, not all the time will be phrased in that way. Okay, so you'll be shocked. Oh, how can this be? I don't study this one like that. But you studied that one, only you did not dig it out. Really, okay? You studied that one, but you did not go to the deep blue sea. Ganon. Okay, you are only in the superficial, in the shallow portion. You will go deep so that you can understand further. Something like that. That's the analogy behind, okay? And then do not too much dependent on, oh my gosh, always like this, and then it will not come back again. Oh, nga. Okay, because it is being presented in another way na siya. Okay, malibog na dayon ka. Okay, just like this problem. This is also tricky problem because this is a Chemical Engineering Board examination, May 1994. Okay, PRC, Philippine Regulation Commission. Okay, so this is, shall we say this is a mass transfer. Okay, because of the diffusion coefficient, something like that, huh? Because the coefficient of heat transfer is thermal conductivity. Okay, and then for the momentum transfer is the momentum diffusivity. In there's already, even though the concentration is not mentioned here, automatically we can prejudge as mass transfer because we need to figure out. That's why I say prejudge, meaning initial judging only at this point in time before we can confirm, unless we will solve to the details. Let's prejudge or prior. Okay, ganon. Okay, so molar flow rate. Okay, guys. Now, that is being asked. Number 2, the given. Oh my gosh. Uy, nakakaloka. Given. Okay, given, CO2 and N2, and CO2 will diffuse. Okay, diffuse like that. And you can observe also, class, that in mass transfer, usually the example are gases and liquids because of the rationale or because of the reasons that these liquids and gases have high diffusion rate compared to solids. Okay, so solids are heavier than liquids and gases, and then liquids are heavier than gases. So the gases are lighter. The molecules are far apart with each other, meaning to say they are highly volatile. Okay, high value of volatility, and at the same time easily diffuse. Okay, so that's the main reason that most of the time the example really are gases. That's why we can easily connect the ideal gas law in here. That's the main reason behind. Di ba, may bomo, kasagaran gases good siya. Just because of that reason, diffusion rate and the volatility, highly volatile. Ganon. Okay, so the given will be now, okay, what, 300 Kelvin. Oh my gosh. 300 Kelvin, total pressure of 1 atmosphere. Okay, 1 atmosphere. And we have a conduit. Okay, we need to draw the conduit, huh? Conduit. This conduit is in a horizontal position because it's mentioned in the problem left and right. So it matters really the direction also. You have to analyze. It's not vertical. See? Okay, at the left end, yung ganon, comparing it for the right end, so you will also analyze in that way. So your illustration is a horizontal conduit, something like that. Okay, so horizontal. Okay, so I'm gonna draw here. Okay, this is a conduit, a horizontal conduit, and this is described as cylindrical conduit, meaning the opening and the outlet opening, right? Inlet opening and the outlet opening are round. Okay, round or circle. So the length is 2 meters. Ganon. Okay. What else? 2 meters or? Okay. And then partial pressure of carbon dioxide at the left. So the left is here. Okay, this is the left, this is the right. Okay, ganon. Label left and right. So in the left, we have 20 kilopascal. Andiyan na naman tayo. 20 kilopascal. And the right, we have 5 kilopascal. Hala. The pressure is not expressed in a very simplest way or the common. The common is atmosphere. So it's expressed in kilopascal. So we need to remember the conversion factor of Pascal with relation to the force. Okay? You get the point? So Pascal, 1 Pascal is equal to 1 Newton per square meter. Okay? So in there, we have the value also of Newton. So Newton is equal to kilogram meter per second squared. And you will play around that unit because since we know there's a molar flow rate half second in the denominator. So it's in there that we can obtain, achieve, and get time in the denominator, which is particularly second at this point in time. Okay? Kaya may book mo ang flow rate, there's a second. It's just because of the Newton thing in the numerator. You have to break down that. This is very important to take note. Okay, students, engineering students, especially chemical engineering students out there listening to me. Okay, Newton is equals to kilogram meter per second squared. This is very, very basic. It always comes out in the examination. Okay, something like that. Very clear. Okay, now. 20 kilopascal and 5 kilopascal. The 20 kilopascal is in the inlet, bigger pressure, and the outlet is the lower pressure because this is just the same analogy with the concentration, from higher concentration to lower concentration. Since pressure and concentration is directly proportional with each other, if we take note the ideal gas law, because we assume here this is an ideal gas law because both are gases. Okay? Mo ni siya ang pinaka-kusog na option. Ideal gas law. It is not very, very logical to use the non-ideal gas or the real gases due to the fact in real gases and ideal gases, as we can remember in our physical chemistry studies, we need to consider the intermolecular forces. Okay, and it's very difficult to evaluate the intermolecular forces of those molecules. So that is the van der Waals equation of real gases and non-ideal gases. That's why automatically we can prejudge or judge directly that we use ideal gas law, even if we will not compute for the compressibility factor as our basis. When can we declare that this is an ideal gas or a non-ideal gas? Okay, or a perfect gas. Okay, ideal means perfect. Okay, ideal or perfect gas. That's what you. What is your ideal woman? So that's almost perfect woman you will be able to choose, okay, to be your partner in your entire life. So that's ideal, meaning highly, highly theoretical, not practicable, okay, because nobody is perfect. So yung ana ra gyud siya permi ideal gas long i-consider because this is the purpose only for the discussion, because if you try to apply this in our real world, you can never say an ideal anymore gases. Okay, why? Because there's a lot of gas contamination and air pollutants in the atmosphere. They cannot behave already as an ideal gas in the first place. Okay, because there's a lot of contamination due to greenhouse gases or global warming. You get the point? In 1800s, due to industrial revolution, that's the time that we achieve the global warming all over the world. And this carbon dioxide release are very huge in the atmosphere, that those power plants, gas plants, petroleum industries are releasing exhaust contaminated gases in the atmosphere. So these contaminated gases or the air pollutants will eaten the molecules of those original gases exist in the atmosphere that God gave to us, which is a perfect 100% oxygen, 21%, and 79% nitrogen free. Okay? Under His creation, free, without any contamination. Since the people are abusing the nature, because we are now industrialized, industrialization is dependent also to releasing pollutants in the atmosphere. Okay, because if we don't release the waste, we cannot produce huge products that we use also daily ala tool. Okay, so if there is an industrialization, it is expected also that we have so many waste. The only thing to do that is to have a good waste management system for our environmental, preservation, or caring of our environment, so that we can attain an environmental sustainability for our future generation. You get the point? So if we'll never take waste management for those waste that we release in the air, in the land, okay, in the water surface, then our future generations, our children will suffer because of our abuse to our nature. So we should not do that. Okay, we should have an effective program for waste minimization and waste management system. And that is the role of an environmental engineer. Okay, environmental engineer role. But also sometimes chemical engineer can do that role because we are more on the environmental chemistry. Okay, so the best option, not all the time, it depends on the ability of the company. Most of the time, companies and industries are hiring chemical engineers for that because we are very, very, not really, not all, majority, we are very, very master in environmental chemistry. Okay, we're studying also the environmental monitoring in the air, in the land, in the water surface. We can study the chemistry on that. So that's why their first option should be a chemical engineer as an environmental engineer. Okay? So disclaimer only, but it depends on the ability of the engineer, whatever course you have. But the preferred only. Okay? Or shall we say advantage. Okay? But not all the time. Okay? It depends on the competency and qualifications of individual who are applying as an environmental engineer. Okay? Disclaimer, kasi basig ningon mo kagara, chemical engineer man siya. No, it's not. That's reality. Okay? They preferred really chemical engineer for that. Okay? So, we should understand that. Now, so CO2 and N2 here is an ideal. We assume, though it's not practicable nowadays, and nadyo daghang kay mga contamination, guys. There are so many chemicals or hazardous air pollutants, really. Okay, so I don't have to enumerate that one. You just research for your own self. Charot. Okay, now we have the pressure 1 and the pressure 2. Why we say pressure? This is called pressure because it is changeable. Okay, from point to point the pressure will change. Okay, that's why it is partial pressure, subject for changes. That means partial, not final. Okay, you get the point? The adjective, partial pressure, atmospheric pressure, absolute pressure, vacuum pressure, gauge pressure. There's a lot types of pressure and you should be careful. Okay? Very clear. Okay, now going back to the given. So, the cross section of the cylindrical conduit having a radius of 0.025 meter at the left. So the left, there is radius of 0.025 here. Okay, half only because radius is the half of the diameter. Okay, so 0.025. Okay, and the other end also at the right is 0.05. Guys, we don't have to illustrate this very precise. This is only for the purpose of discussion so that we can understand what's going on. Okay, in here it looks like a little bit wrong because in the diameter of the outlet is higher than the inlet, but I just put that the same only for the purpose of discussion only. Okay, we should not draw because I am not an architect also or a fine arts that always usually make it good in the drawing and the illustration. Okay, discussion na siya. Okay, so I don't have to use the roller just for that. Okay, so actually the end has a higher diameter a little bit at half. So it's supposed to be, my illustration is a little bit bigger compared to my inlet diameter. But for the purpose of discussion, we just imagine that it's gonna be like that. Because I told you a while ago, over and over again, engineers are having a critical thinking and wild imagination. Wild imagination meaning we maximize our comprehension mathematically and scientifically. It's always like that. Mathematically and scientifically. Okay? So, maximize. Always in the maximum side, not in the minimum. Okay? Okay, very clear. Okay, now, this is enough? Oh, we will put that diffusivity, mass diffusivity. Guys, mass diffusivity gani siya, it is diffusion coefficient in mass transfer. Okay. So, diffusion coefficient. So, this is denoted as DAB in most of the books declaration. If you have books, what do you call this one? Transport phenomena. Actually, this is transport phenomena book, major chemical engineering subject. And this is subdivided by momentum transfer, heat transfer. If you have that book, always DAB is the declaration of this mass diffusivity or diffusion coefficient. So, capital DAB. Okay, like that. Capital DAB is equal to 5.0 times 10 to the negative 4 meter squared. Now guys, you have already given the data here. So the next step is you need to think what are the suitable formulas and equations to be used. Okay? Oh my gosh. Let's just imagine, how can I do this? There's no concentration since we know mass transfer is a transfer of one component from a region to a higher, from a higher concentration to a lower concentration. But in the problem in the first place, there's no concentration. How can we do this? Since I told you, we need to correlate this to ideal gas law. And we need to derive now on the spot. Okay, because we have no concentration or else we cannot use the equation. Okay, so we use the original equation first in mass transfer. So we will say, okay, we will say that, okay, molar flow rate, okay, molar flow rate is equal to the negative diffusivity, mass diffusivity, like that, and then delta change in concentration, okay, and delta change in the length, okay, this one, okay. Delta could also be expressed in triangle, small triangle, or small letter D. It depends on the book, what you are studying, because it's gonna be small letter D, it's gonna be a smaller triangle. It depends on your instructor, but it's just have the same meaning. Delta and change for chuba chuchu. Okay? Chuba chuchu meaning anything, any quantity. Okay, always say chuva chocho, right? Meaning anything. Okay, so like that. This is molar flow rate or the molar flux. Now, we go to the mass flux. So the mass flux is MA. Okay, so MA is equal to, again, the same story. Okay, diffusion coefficient, then delta change in concentration over delta change in the length. Okay, now this guys, when I keep on studying before, when I was in college, okay, I understand also, but not really that super high. Okay, but now, oh my gosh, it's very clear to me now. Okay, but sometimes really, I don't think so. It depends on the instructors, right? Okay, some instructors will not elaborate effectively to the students, and oh my gosh, we cannot blame them because they're also trying to catch up the time. I think only 1 hour for that subject. Another subject will come. That's why they will try to cut off. So there's a reason for that for sure. Okay, but if only the instructor will discuss that this gonna be the case, that's why it's be cancelled like that, then the student can easily understand. In here, okay, I'll tell you. I will be based on my confession when I was in college. Okay, I memorized this too. Okay, the molar flux and the mass flux. Okay, then I don't have an idea that that flux is the same as molar flow rate, mass flux. As long as I know that that is the flux. Okay, because just now I do a lot of research na naman talaga when I'm already licensed chemical engineer. But before, nag-study lang ko, daghan sad akong study, but not that comprehensive. Okay, how can I say this? Not to the bones, or not too much digging it out. But now I can dig it out during my day offs. Okay, because I don't have work in Friday and Saturdays. So all I have to do, I have to develop my content. And my content is science, physics, chemistry, and chemical engineering major subjects, and sometimes a little bit of mathematics, okay, and safety, right? That through that time period, oh my gosh, I can understand that's gonna be the case. Okay, when I was in college, oh my gosh, there's a little bit of confusion. At least I'm clear, ganon siya. But it took me 21 years, year 2000 from now. It took me 21 years just to further add my knowledge. Imagine. So, oh my gosh. But it's okay. I'm just sharing to you what's really happening, okay? Like that. Because I will develop content in my YT. Okay? Or else I will be kept on singing karaoke videos, then I don't have revenues. Okay? Because they will file complaint against copyright claims. Okay? Copyright claims meaning you are using the music of other people in order for you to sing. And that music belongs to other people. The uploader is not you. So when the administrator will check that out, it will not pass the giving of the revenue, something like that. Okay? So I have no choice, right? So it's to do personal vlogging or safety or my profession as a chemical engineer, of course. Okay, that is more confident because that's my profession. Of course, I don't have to, think for others. Okay, then I found also boring cooking because I don't know how to cook. I don't have talent in cooking also. For speaking capability and to communicate and to convey to my audience, no problem. But for the content, okay. Step one, mix this, ampalaya to eggs, and then I don't have an idea because I don't have, inclination in cooking. So that's why. And then if I'll cover also politics, I'm not good also in law, LAW. I don't have too much background in political science. So how can I relate also? Okay? And then if sports, I don't know how to play basketball. Okay? But I know how to play volleyball, but I'm not really an athletic when I was in my high school, elementary. So I cannot also share that much. So the last option is for academic information. Okay? And then I cannot also share to you English, since I'm good also in English. I cannot also share to you about the topics in English because I'm not majoring in English. Okay, I'm not major in English communication, so maybe somebody will correct me all the time because it's not my line of specialization. Despite that I know how to communicate spontaneously in front of you guys. But speaking in front of you fluently is not a guarantee that you are good also in spelling, in grammar and everything. Unless you are majoring that specialization English. But I'm not majoring also in English. Right? Correct. Now the last option will be in science. Okay, because I love chemistry, I love physics, okay, something like that, and I am a chemical engineer, so it's easy for me to relate mathematics, chemistry, and physics. Okay, so that's the last option. Then if I have to vlog also OSH, I'm tired of doing that for almost 15 years in my life. And go internationally, different countries, still safety, 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 a la tool, like that. Okay, me, I found boring and monotonous also, since 2004? No, from now, still safety. Okay, no, 2000 plus, yeah, 2007. Okay, so when I was in Taiwan, right? Taiwan, and then after that, I go to state of Qatar, and after that, I go to Abu Dhabi, UAE. Okay, after that, I go to, Jubail, Saudi Arabia. And after that, here. Okay? So, from Philippines originally, after my graduation. Okay? And then, second, Taiwan. Okay? Third is in the state of Qatar. Fourth, in United Arab Emirates. Number 5, Saudi Arabia. So my fifth and last experience in Saudi Arabia, something like that. So in that alone, it sounds boring for me to keep on vlogging about OSH. Okay? So that's why I shifted to my profession, science, physics, and chemical engineering because I love it. Okay? Dali na kay siya. Okay? Kaya maong dyan na akong nakuan dyan na master. Charot! Okay? Charot lang. Okay? So, and then I will also share a little bit because I took my, my masteral also in University of San Carlos. But I did not finish, okay? I did not finish. So, I have also an idea about, taking up masteral, something like that. So, I didn't finish my masteral study also, okay? Then since environment is connected also with chemistry, and, environment. There's a lot of chemistry in the environment. That's why we have environmental chemistry for land, water, and air. Okay, you have to know the chemistry for that. Okay, because this is the habitat we live in our planet Earth. Okay, so that we can survive, then we should know the chemistry in the land, air, and the water surface. Diba? Ganun yung mga scientific approach. Okay, going back to the mass flux. Okay guys, now as you can observe here in the mass flux, the mass flow rate, oh my gosh, Sir Sotero, it has the same formula. Yes, I know. But the problem is, before, they are not stressing. I do not blame my instructors before, as I told you, disclaimer. I will not blame. Okay, for me, in fact, that is good in order for the students to research more. Yes, okay. But if there is time, then help the students also. Okay? Now, this one, mass flux, we need to divide this to the molecular weight. Okay? In order to become molar flux. Di ba ang molecular weight or molar mass is grams per mole? When we multiply the grams per second, which is the mass flow rate, we divide that to the molecular weight, we cancels the grams. What will be left is the mole per second. It will now become the molar flux. Okay? Kay maobya dyan siya standard guys, ang mass flux. Okay? The mole flux is just only secondary. Okay? That's why it's called mass transfer. Naingon ba ang topic ng mole transfer? It's not. Right? It's always momentum transfer, heat transfer, and mass transfer. It's not mole transfer. So the mole transfer is only secondary, okay, from the mass flux. Okay, since we want it to become mole flux or molar flow rate, then we need to divide that with the molecular weight so that it will become mole per second. So the unit of molar flow rate or molar flux is mole per second. Okay, and the unit for mass flux or mass flow rate, okay, with regards to mass transfer. There's also mass flow rate with regards to the momentum of God. Okay, so the unit will be kilogram or gram per second. Okay, you get the point? And the original formula doesn't involve molecular weight. That's the problem. Okay, so sa dali ra jud kay sa abtik lang makahuna-huna. Ang what if ang dili active ang abtik mo, mabiyaan jud siya. Okay, so that's why if I will be the mentor, I will teach the students. Guys, divide this with this if the problem will ask to this, right? Am I correct? Okay, so it's gonna be the proper approach of discussion. If we have more time, okay, something like that. Okay, so it's gonna be like that, guys. So we need to divide this with the molecular so that it will become Na. Okay, now mention here equimolar counter diffusion. So what's gonna be the theory for this? Theory. So obeying the steady state, okay, of motion. So this is gonna be Na is equal to the negative Nb. Okay, Na is equal to the negative Nb, meaning equilibrium with each other. Component molar flux of A is equal to the component B molar flux and negative because he is on the other side. Okay, algebra again. Positive, right. Negative, just remember the quadrant topic of algebra. Okay, right positive, left negative, upward negative, downward negative, upward positive. And you can say quadrant 1, quadrant 2, quadrant 3, quadrant 4. So that is very useful also here. Okay? Because it involves sign. Sign, negative sign, something like that. So maybe say, oh my gosh, it's gonna be on the left side. Because our conduit is horizontal. Okay? Alangan mo yung downward, upside, atong conduit horizontal. So, sami. Okay? It's gonna be like that. Okay, now. Hala, oy. Saan na nato ron? Okay, in physics class, we don't need to deal the limits and the derivation on the calculus and limits, ganon. Wala siyang nga na ha. Mudit surat sa katungkuan, Jud. Ay, surat. Kaloka. Now, since we need to account the flux, we need to put A in the Na. So Na is equal to negative DAB, okay, DC, DL. Okay? So mo na ni siya hostisya karon. Okay? Mo ni siya ang hostisya na pinaka-correct na gid siya nga kuan. Formula. Na over A is equal to negative DAB, DC, DL na area sa denominator. Why? Because the unit of diffusion coefficient or mass diffusivity is area divided by the second. So if that is the case, it will be cancelled somewhere along the way in your computation. Okay? And then you will need to cross multiplication. X, the direction of your multiplication is going to be like this. Na is equals to negative DAB times the area DC DL. Ganon. Muna siya. Na, nawala na ang area kaya nag-cross multiply man ka. So Na is equals to DAB area DC DL. Okay. Now, in your problem here, do you have concentration? You don't have concentration, right? Then you have the ideal gas law. Okay, PV and RP. We're concentrating, right? Concentrating also concentration, right? We are focusing on the concentration. So use the PV in RT. Okay? Yes, nakalimot ko who discovered ideal gas law. It's gonna be Clapeyron, right? Okay? Mo ba na siya? I forgot. Because the ideal gas law, someone who discovered that one. I forgot. Okay? I think it's gonna Clausius, right? Or Carnot, Mr. Sadi Carnot. Okay? It's either of the two in the second law of thermodynamics, right? Because Sadi Carnot states that, the cyclic process of the heat engine, ganon, is dependent on the temperature, right? Heat absorbed, ganon, is equal to heat release. But it's gonna be Clapeyron, okay? But never mind. That's thermodynamics. Okay? So going back here, so PV in RT. Okay. Okay. Basta inyo lang dyan timanaan dyan, heat engine gani, Sadi Carnot. Okay? That's why we have Carnot cycle. Carnot meaning silent T. That's why we have Carnot cycle in heat engine study. Okay? Heat engine. More on mechanical approach when we deal with engine, right? Okay, so PV is equals to nRT. Okay, now we need to have the concentration. Concentration again, moles per liter. Moles is small letter N. Liter is capital V. So C is equals to N over V. Okay. Moji na itong buhaton per sa derivation first. Start with the general declaration of the variable. And the final will be the breaking down of units. Okay, guys? So, concentration is equal to N over V. Okay, then N. Solve for the value of N because N is in the equation of the ideal gas law. Okay, so N is equals to CV. This is not the ratio mean. This is concentration times the volume. Okay, so PV is equals to the value of N here that we will solve now as CV, right? Substitute in N, small n. So it will become CV RT. Now, volume in the left side and volume in the right side will be cancelled. In theory, it's always like that if it's opposite with each other. It will be cancelled. So what will happen now? So concentration is equal to, or pressure is equal to CRT. Okay, pressure is equal to CRT, or concentration is equals to pressure over RT. Okay, now we have DC. DC here in our formula here is the change in concentration gradient. Substitute this, okay, C is equals to PRT because concentration man natin gamit ani nga mass transfer. Even if we don't have concentration, but due to our derivation, we solve the value of C in terms of the variable declaration. So C is equals to P over RT. Substitute that here in the DC. Okay, the change in concentration. So it's gonna be P1 RT1 minus P2 RT2. Because C1 is equals to P1 R1 T1 and C2 is equals to P2 R2 T2. Okay? So just i-substitute in mudrari atong sulod. Okay. So dili na ka mahadlok nga wala siya concentration kay makakorelate man ka. Okay? Muna technique ka sa mga problem solving. Okay. So we have NA is equals to negative DAB. Tuluan sa tamo sa technique ka nang mawala ang negative. Kali. Sapot ko na sa ulit. Ito ko kasabot. Okay. DC DL. Okay. Then this become now NA is equals to negative DAB. Okay, guys. Nakakaloka, no? Okay. Nakakaloka. So, A is equals to the concentration. Kani guys, nakalibog na niya siya. Diba ang theory, usually diba, final minus initial? You get the point? You will always say na, T2 minus T1. Yan, ingon ta sa transport phenomena. For example, I have the momentum transfer topic. That the component will move or in motion from higher temperature to lower temperature, right? We say that. You get the point? And we will say T2 minus T1. But take note, the T1 in our illustration is higher temperature than the T2. Kiningon ko tagod, from higher temperature, mag-start ang from initial baya. It's not T2. And then why we say T2 minus T1? It should be supposedly T1 minus T2. Again, di ba, kasagaran sa mga formulas in engineering, okay, always like the T2 minus T1, C2 minus C1, V2 minus V1. Now, in the topic of with our physical chemistry or thermodynamics, let's dig it out. Why? Okay, that's the most intelligent question is why. Second is how. Okay, if you understand the whys, then it's easy for you to understand WHY. Okay, because this is a smart question. Okay, you need to know why. Okay, now T2 minus T1. Now, T2 is in the output, right? In the final stage. Okay. T1 is in the initial stage. Okay. At the rest, there is higher temperature. From man siya. From higher temperature to lower temperature. So that is T1. Supposedly, it is T1 minus T2 because T1 has a higher value compared to T2. You get the point? And then why our instructors will say T2 minus T1? Oh, di ba? Kung higher concentration ng origin, di mahimo na siyang positive, iniga subtract nimo. Okay? You got the point? Nakakaloka, di ba? Muna siya naitabo. Now, in here, i-correlate na nato sa dito sa mass transfer. Okay. We have a negative diffusion coefficient. Now, in my part, I need to eliminate the negative because for me, maglibog ko. Okay, so the technique in removing this one, okay, is to change the gradient. You got the point? Okay, so mahimo na ni siyang T2 minus T1. Katong gipang-ingon sa atong mga instructors. T2 minus T1, C2 minus C1. Kay, kuan man siya, dako man ang unahan. So mahimo siyang positive. So dili na ka magbuhat og negative diri sa kilid sa coefficient. For example, mass transfer here, di ba? Niingon, C2 minus C1. And then the C1 is higher always than C2. Okay, high concentration. So, for example, if you have a 2 moles per liter in the end, and we have 4 moles per liter in the initial. Since you say C2 minus C1, right? So, it will be 2 minus 4. So, negative. Okay? So, kung C2 minus C1, that is negative result. So, if we times that negative in the coefficient, then it will become positive. You got the point? Muna siyang C2 minus C1, T2 minus T1, ganun. Kaya na yung negative nga coefficient here somewhere along the way para makancel siya. Now, kung imo na siyang balihon, mawala na siyang negative, imo na siyang C1 minus C2, T1 minus T2. Okay? Ako naman ang giderive niya. Maglibog pa siya ko ba? Okay? Naglibog ko kaya mga approach in the, in the references that, oh my gosh, why is this negative? I don't know. Like, gi-change lang din niya mo din mahimo siyang positive. Okay? Just like in electrochemistry. Okay? So, for example, Nernst-Simon equation. So, electrochemical cells is equal to the electrochemical cells A potential standard minus ganun, diba? 0.0591 over the number of moles. Like that. Logarithm. Okay? Logarithm of the reaction quotient, which is the product over the reactant. Something like that. Now, if you want to have a positive without having negative, if you have to plus, for example, E cell plus, dili siya minus, then you have to balitok. Imong i-reverse ang product, maato na siya sa ubos, ang reactant maato sa taas. Okay? Kaya gusto mong kamo plus ra. Kaya standard formula ana ba ya? E cell is equal to E standard minus 0.0591 logarithm. Mahimo na siyang positive, so imo siyang ibalitok ang reaction quotient para mahimo siyang positive. Okay? It will become logarithm of reactant over the product. Mausa na siya Arrhenius theory equation. I already proved that. Okay, katong mga T2, T1, gano'n. Ay, negative man yun. Ako yung ituki, dugay ko natug. Ang mo din na siya. Kasi nga nga situation, you have to reverse. Mo sa na ari sa mga gradient. Okay guys? Di ba na siya discuss sa maestro sa maestra? Okay, sa makakuha ra. Ana abaya na, when you go to school, they will teach the proper way. And then if you did not understand, malay ko ba kiver. Ganon. Okay, so it's up to you. They will never force you to learn this. They will never do that as long as they are paid. Okay? By their salary. So it's not like that. So the only way to do that is to really dig it out, investigate further. Okay? So anong mawa ang negative, ganon ha. You get the point? Okay. So, ganun siya ha. So, okay. So, CA2, mugamit ang CA2. CA1, katong ipang tudlo na dyan sa mga instructors. Ako lang siyang i-explain ba nga mawa ang negative. Okay? So, over DL. Oh my gosh. Okay guys, are you still there? Nakakaloka. Are you still there guys? Okay. So L. Ganon. So this is the length. Okay. Actually guys, DL also a change in the length, the direction of the horizontal axis. But in here, there's no change of length. It's permanent. Okay. The length of the conduit. Okay, because sometimes x2 L1 minus L2 baya kung duha ka bukong length gidi given. Something like that. So, okay? So, ganon. So, you will say this as NA is equal to negative coefficient, then ganon, chuka-chucho, CA2, P2, R2, T2, minus P1 R1 T1. Ano na siya? Times L. See? Okay, now you need to simplify further. So take note guys, the capital P Kelvin and the R, you should know and memorize the values later on. Okay, so most of the makalagert ang the value of specific gas constant and universal gas constant. So, I will tell you anong makalagert later. Kay the value sa R, but you will memorize only at least 2 and least 3 and the others will be derived also again by the ideal gas law. Okay? But it's easy to solve with memorized values, right? Okay? So, it's gonna be like this. So, kung ingani ang istorya na itong karong higayuna, so we have NA is equal to negative AB area. So, we can say that also as ganun siya. So, if we try to break this out, okay, I will emphasize this in detail, okay, so that we know, it's gonna be like that. Okay, so P2 RT2, this is an example. So it is over L, right? In mathematics or in algebra, okay, pressure is equals over R times T divided by L. So L meaning here guys is only the numerator. So if it is only the numerator, you need to over that with 1. Right? If you multiply that here to the numerator, it will balitok. It will reverse. It will become 1 over L when you multiply that in the numerator. So this is a rule. Okay? Or else, you will put L raised to the power negative 1. You got the point? Because it should be going down, not going up. But if you want to multiply that without having a negative sign, negative 1, then you will say, guys, 1 over L. Okay? That's very clear, ha? Mujini kasagaran masayog ako, masayog si Kuperniani. Okay? Masayog si Kuperniana, guys, na mo gamit ang ana nga. Kuan ba, balitok na ako sayok. Okay? Okay guys, so ang mahitabo ni ini is equals to P2 R2 T2 times 1 over L. Muna ni siya. Okay? So if this is the case, this will become R2 T2 times L. Ganon. So P2, oh my gosh. P2 R2 T2L. And this quantity, you will put that here, in your original equation. So it will become now DAB, okay, P2 minus P1, because there's also P1, RT1 and T1 man. So over L. Okay, now your RT will be now here, because common of the two. And you will say to me, sir, well, common, the other is 2 and the other one. In this, guys, in this situation, the universal gas constant of 0.1 and 0.2 is just the same ang good siya. So you will just denote that as simply R of the 2, of the nitrogen and the carbon dioxide. And the same also with the temperature, so there's only T. So, i-add to mo sa kilid ang RT. Ari na siya din sa kilid. So, muna na siyang naitabo. O, kana. So, DAB over RT times pressure 2 or pressure 2 minus pressure 1 over the land. Then investigate the given andita here. Then ipasok niyo sa na derived na equation. Plug in and solve for the molar flow rate. Okay. So see, even if there's no concentration, we can still solve. Okay, we are not limited only that because mass transfer is the driving force is concentration gradient, and you have to wait concentration will appear in a problem. No, it's not like that, huh? Okay. So now you will substitute values na talaga. Okay. Oh my gosh. So press DAB. Yung mo din yung kopyahan ng formula. So let's do the substitution directly, ha? Okay. NA is equal to negative diffusion coefficient, which is equal to 5 times 10 to the negative 4 square meter per time S. So 5 times 10 to the negative 4 m squared over S. Put a bracket. Close and open parentheses so that it's easy for you to segregate or be confused. Okay. Times, what's that? Area. Now, here. The area here, what you will do for this area. Actually, guys, there are two types of area here. Okay? You say there is a diameter of ganon siya, di ba? Okay. Having a radius na siya ang given, radius. So, 0.025 in the inlet and 0.50 in the outlet. Now, guys, di ba we have the cross-sectional area ng pi r squared? Okay? Do not be shocked and surprised that other references or other reference book use pi d squared over 4. Because it's just the same. Okay? Pi d squared over 4 is equals to pi r squared. Why? Because d is equals to 2r. Twice the radius, and then if you do the mathematics for that, it will become pi d squared over 4. So that's why you should dig it out. Oh, why there's a diameter here and radius only is the given? Okay, something like that, because you have the full knowledge what is an area of a circle all about. Right? There's a circumference, 2 pi r. There's a diameter, 2 times radius. And there's an area pi r squared. And there is also another formula of area which is pi d squared over 4. So the best thing to do that is to memorize all formulas of the circle. So that dili siya makalusot ba. Muna kita wag maximization, maximize the learning na imo yung isagad, so that if there any possibility asked in the problems, you can easily troubleshoot how to answer it because you maximize. You get the point? That's it. Not limited to some quantities, you have to extend farther. Okay, but of course you need to develop the basic foundation first, And then if you have too much time, go to extend, like that, and put that in your brain cells. And then such time it will become solid foundation in your cerebral compartment in your brain. Cerebral, in the compartment of your brain. Okay, that's a cerebral. That's why we have cerebral hemorrhage in the brain. Okay, in which the information will be stored there. Okay, like that. You got the point? That is cerebral, cerebral infarction. Sama ng cerebral infarction, that is stroke. Myocardial infarction, sama na siya, that is the silent killer, heart attack. Cardiovascular disease. So if the term will be like that, that's heart attack. In the news, you will read the news and somebody died in the myocardial due to myocardial heart attack, the same. Okay, that's a technical term, more precise than heart attack. Heart attack is general, but the specific medical term for that is myocardial infarction. Okay, and for the stroke, it will be on the brain. That is cerebral infarction. Okay, very clear, huh? Okay, just like the loss of smell. What is the loss of smell? Okay, that is called anosmia. That is the medical term for the loss of smell. Okay, and what is the medical term for the loss of taste? These are all the symptoms of COVID, 19. The loss of taste is the asgeia. Okay, so that are medical terms. Anyway, we don't have to study that because we are not doctors, we are not nurses, but for additional learning only. Okay, you get the point. Okay, so if for extra lang siya, it's not really that, okay? So, negative 50 times 10 to negative 4 square meter per second. And then, ato na siya i-subtract, guys. Diri ari. Okay, ang area na to is pi r squared. Take note, r squared. Pi r squared. So, do we take the 2 radius or the only 1 radius? Think dayon ka. Okay? Because there are 2 radius. This is another case because most of the problems also only 1 radius. Because the radius there is not changing also when the chemical will go to that medium or the pipe or whatever. So in this case, the diameter changes man good siya. So what will we do now? There's a different radius. And then we know that cross-sectional area is pi r squared. Okay? How can we do that? Okay, do we have to take 1 by 1 and take the area, or we have to put that automatically in the pi r squared? Okay, because we can also have area 2 minus area 1. Okay, area 2 is equal to pi r2 raised to the power 2 minus pi r1 raised to the power 2. R1 raised to the power 2. So that is area difference between the inlet and the outlet. Okay, that's technical, more technical compared to the pi r squared na i-substitute mo ang R1 and R2. Okay, so which is more correct for that? Do we have to do that or not? No, we don't have to do that area difference. Why? Because the area here is not gradient, it's not different, it's not delta. Okay, muna siya ang mga teknik-teknik dirahara. If only delta change, difference, gradient, mo to siya mag-final minus ka, final minus. But if not, do not do that. Okay? Now, yes sir, we don't do that. But there are 2 radios. How can we do this? Okay? Now, the formula of cross-sectional area of a round shape opening is pi r squared. Then that is squared, right? So use the 2 radius. Okay, the radius inlet and radius outlet. So it's just the same R2. Okay, because both of them are radius. Okay, they have the same unit. So parallelism and similarity. So that's the logic. Okay, if there is a logic valid, okay, then use it. If there's no validity, you cannot use that. If there's no sense of using it, something like that. Just like ratio and proportion, interpolation, you cannot just interpolate without correlating the quantities. Okay, you should know how to, to troubleshoot the similarities, the proportion, like that, and whatever chuba chucho, you know what I mean, okay? Something like that. So this is gonna be pi times R1 inlet na 0.025 times, okay, times the 0.05. Okay? Dili siya itag sa tagsa og square ha, kay masayop mo, ana mo nga, pi 0.025, irisa mo sa 2, niya katos ang radius mo sa irisa 2, na masayop ka. Kay dili baya pi R4 ang area. Pi R squared ra baya. You get the point? Oh, so imong gamiton siya kay R squared naman na siya, ang usa ka R radius in the outlet and radius in the inlet. So both of them will be raised R to the 2. Still, that is the area of a round circular sectional area. Okay, so it's gonna be, okay, I will break down this as pi times 0.025 times 0.05. Di ba mo matter ng interpretation, right? Okay, so times, okay, here, pressure 2 minus pressure 1. So our pressure 2 is 5 kilopascal. Okay? Now guys, this is kilopascal. Be careful. As I told you a while ago. Better talaga siya guys to convert first. Okay? So 5 kilopascal pila man siya. How many pascal? Okay? Like this. So 20 kilopascal sa yun ra siya. So 1 kilopascal 10 to the 3, right? Correct? So 1 kilopascal is equals to 10 to the 3 pascal. Cancel, cancel. So times 1,000, it will become 20,000 pascal. And the other one, so 5 times 1,000 automatically, that is 5,000 pascal, right? Okay. 5,000 pascal. Muna siya mong i-minus. Dili ang kilopascal ha. Why? Because that is not similar with other units there. There. That is not kilo. Here, the other units here that I presented a while ago, that's not kilo. This Newton meter squared, and ganon. So that's kilo, so problem. So you should break to the pascal only. Okay? So this is 20,000. No, 5,000 minus 20,000. Okay? Ganon over the length which is 2 meter. O, ano siya? Solve na yun. Guys, it's better to transfer the units down below so that it's clear for you to cancel out rather than you will put beside. Okay? Because you will confuse. Or you will segregate the units just as is the numbers there, and then later you can come up with a simplified unit. Okay, we'll show this meter squared. Okay, second. So meter raised to the power 2 is square meter. Correct or not? Square meter, right? Okay. Square meter is the basic unit of a lot area when you buy house and lot, right? Square meter. Okay, so times 15,000. This is negative. This is pascal. Okay, this is Newton meter squared over meter masadang ubos meter. Now, imong buhaton na niya, you should do first the cancellation first before breaking the Newton. Okay? So, cancel first what is being cancelled for the moment. Okay? So, here, what is being cancelled is M2 and M2. So, what will be left is M2 second and meter. So, here, the meter also will be cancelled because M is in the numerator. Okay, so N cancelled also, M2, M2, and then M. So, what will be left here is meter per second, which is the velocity. See? Velocity. Velocity seconds times the Newton. Pa. Now, second step, that's the time you will break down the Newton. Newton is equal to kilogram meter per second squared. And then multiply that with the meter per second. And let's see if this is the unit of the mass flow rate or the mass flux, or this is the unit of the mole flux or the molar flow rate. Let's investigate first. Okay? So, M over S times kilogram meter per second squared. Then, ganun siya. cancel. So this is kilogram, kilogram meter squared. Okay, kilogram meter squared over second. Kilogram meter squared over second. Okay. Actually, guys, this is the mass flux. Okay? But since this is not yet mass flow rate, you need to investigate, oh my gosh, there's an area in the denominator. So, you have to reassess. Okay? Actually, sakto na siya. Mass flux na siya. Pero imong balikon kay gusto jud nimo mass flow rate ba? You got the point? Kay imong target kay kilogram per second naman yung habilin. Okay? So you need to revive a little bit. Okay? Because if you use this, there's no problem because there's an area. We can cancel that out with the area. But remember, we used already the area in the original equation. So there's a redundancies of declaration. Something like that, but you have to think. Okay? Because if you again multiply with the area and you used that area before, so there's a redundancies and duplication of entry. Maybe you will be wrong. Okay, so this normal process in solving. You have to review because maybe it was being redundant after all. Though we can cancel immediately with area here, it will become the mass flow rate automatically. Sure, see? Okay, but we need to go back a little bit. Okay. Okay, investigate one by one. Okay. Ganun talaga siya parati. Okay. So NA is equals to ganun siya. Wait guys ha. So, meter squared over second. And then pi r squared meaning meter squared, right? So, meter squared. And then, pressure. Pressure is expressed in Pascal. Meaning to say, Newton meter squared. Okay. Ako yung tagsa-tagsa to make it sure. Okay, so over the length is the meter. Okay, now this is n to the 4 over second, and then n to the n2 over n. See? So we need to cancel first at the numerator. What is available? Cancel here. n2, and this still remain 2. Okay, this one. Now there's still m in the numerator. So you can cancel this out. Oh, just wait for a while. Break down muna ang Newton. Let's see what happens. Okay. So m squared second kilogram meter per second squared. Ganon. And then this is gonna be cubic meter kilogram cubic meter. Okay. Then it's gonna be s cube, right? S cube. S cube over meter. Okay, ganon. So, cancel the meters. It will become kilogram meter squared second squared. Ganon. This is the unit of your Na. Now, you will try to assess the molecular weight. The unit of weight, molecular weight is kilogram per mole because in terms of kilogram is siya. Okay, you get the point? Ako ninyo ang point. Charot! Okay. Nakaloka. Okay? So, muna siya netabo. So, pili answer ano niya. Ato sa siya i-answer dyan ang yung values. Okay? Wait for a while. 5,000. So, 20,000. Charot. 20,000 minus 5,000 is equal to, okay, 15,000. Atong tagsa-tagsaon guys para di ta masayo. Okay. 0.05 times 0.025 times 3.1416 is equals to 3.927 times 10 to the negative 3. Okay, times negative 4. Okay. So that is negative. Plus 5,000 minus negative. It will be negative. So negative times negative. Di ba positive? I told you a while ago. I discussed, right? So, muna siya natabo. So it's gonna be negative 15,000 times 3.927 exponential negative 3 is equals to times 5.0 exponential to the negative 4 is equals to divided by 2.
So we have 0.0147. 0.0147. Now let's investigate the unit for this, okay? As I promised. Ganun siya. So, ato na siyang i-break down. Ganon. Okay? So the unit, guys, we have the kilogram meter per second squared. And then, let's go back to our formula. It's in here. Our formula is in here. Okay. Napa siya R of T. So I told you, we need to go back is something, there's, you will feel that really, okay? So there's something, something lacking like that. Okay? Your brain cells will tell you through that, okay? So RT. Oh, ganon. So there's still RT remaining. Ganon. So that's why, ang buhato ni ini, so diri pa lang daan, imo na siyang gibutangan og unit ang R. Ang R diri mo na ang lisod. Ako, di ba? R. R, specific gas constant, universal gas constant, and gas constant. Now, ang R, puting baga ang unit ani niya. Okay, but ang the most common sa chemical engineering ang 0.08205 liter atmosphere mole Kelvin and the 8.3145 joules per mole Kelvin. Now, the unit doesn't involve joules here in this mass transfer. So what is the more closest unit for this here? Diba? Pagkain mo kasi mong self, oh my gosh, there's no other unit, there's no energy here involved. What can I do for that? Ganon. Okay, so the best thing, the last option is, diba, we have 0.0825 liter atmosphere. Or sa man ang liter? Diba, volume. Okay, so the unit of it could be expressed also sa 1000 cc. 1000 cubic centimeter is just equal to 1 liter. And 1000 cubic centimeter is just equal to 1000 milliliters. Okay, so 1 liter is equals to 1000 cc. Cc means cubic centimeter. Okay, kay gitapol og suwat ang mga author sa book, munang cc na lang ang gibutang. Pero actually, it's better to put that as cu tuldok, cm tuldok. But, to make it short, cc. Okay? Because there's also cc in the email. Okay? When you email somebody, you put in the cc, right? 2 and cc. So, it's also confusing. So, the best thing to declare an acronym is there's no redundancies and there's no duplication of other meaning. So, that's the most safest way how to put an acronym. Okay? So, for example, GMA, Greater Manila Area, but that's also Gloria Macapagal Arroyo. You get the point? So, it depends on what you are referring to, but it's still confusing for others because there's the same definition. So, avoid that kind of acronyms. Better use the complete. Okay? So, Greater Manila Area, Gloria Macapagal Arroyo is still GMA, right? You get the point? Mausad ni siya. Okay? So, ang atong buhaton ni higayuna, diba? Liter atmosphere mole Kelvin. Atong suwayan. Okay. 0.0825 0.8205 liter atmosphere, okay, mole Kelvin. This gas constant, guys, have 4 units. 2 in the numerator and 2 also in the denominator. So this is very, most of the times, only 3, but this is special. 4 units talaga siya in a row. Something like that. Okay, so this way. Ay, nako. Okay, now so this letter atmosphere, so duha yung problema ni higayuna. Liter atmosphere, you need to convert that to cubic meter to agree with the meter in the Pascal. And then you have also the atmosphere for siya, in which yung imong pressure nga gamit dito, not atmosphere. It is, ano naman to siya? Kilopascal. So it does not agree already. So if I will use this one, I will convert the 2 units in the numerator. So how about using the other one, which is 8.3145 joules per mole Kelvin. Di rin nata sa pag-substitute ha. Kaya nabay RT atong denominator based in our derivation. Atong utang values. Mao to nga akong nakuha diri, naglibog ko kay taas pa kay siya. Dagan pa kung i-cancel ba, di mo makatugot akong brain cells. Muto nangita akong paagi akong gi-review. Mumuha na siya, nasakpan dyan ako. Ingana ha ang style. Okay? Review after. Okay, but if okay na, no need to review, right? Okay, but in this case, akong gi-review kay na may mga confusing parts. Okay, ganon. Which is a normal process talaga in solving problem. Okay? So, ganon. And we use the 8.31 for, let's try. 8.31, popular sa siya 3.45 guys. I will tell you something. 8.3145 joules mole Kelvin. Do you remember the Faraday constant in electrochemistry, capital F? So this 8.145 joules is used there. Okay, another thing also. This is also used in the Max Planck, no it's not, Ludwig Boltzmann constant. In entropy, in the, it's gonna be the second law of thermodynamics, okay, discovered by Mr. Ludwig Boltzmann. The entropy of the molecules in its microstate. And then that's why it becomes a Boltzmann constant because of him. Okay, so the 8.3145 joules also is used there. So this is useful constant really. Together and paired with the what? The Avogadro number. Okay, so if the question in the future exclamation will say, what gas constant should be used to achieve and to obtain a Boltzmann constant? A, B, Your answer is this one, 8.3145. Because no more time to convert. It will take a longer time to convert this. Really sure, just to attain the the Faraday constant like that, it will take time. So if you memorize this in your brain cells, you can easily answer the multiple choice question theory, something like. But you can answer that also through solution. But if you memorize that, you can save your time. Okay, question like it's blank can be used is a constant that can be used in the Boltzmann constant like that. Okay, and in the Faraday constant. This is 8.3145 joules mole Kelvin. Mo siya ang gigamit nga constant, guys. Nga gi-multiply mo siya sa Avogadro number. So basically, if you want to become chemical engineers, okay, you need to memorize this Avogadro number and this constant. Okay, magamit na siya per me. Okay, something like that. So, or you will memorize all the constants. Okay, so that's gonna be. I do it in my college. Okay, and then I was just refreshing now. Okay, really. Sakit ka kung ulo kung higayon nag-memorize yun ako ng mga constants, gravitational force constant, Faraday constants, Coulomb constant, Avogadro number constant, ganun permittivity constant, permeability constant, gravitational force constant, Boltzmann constant, okay? Something like that, Stefan Boltzmann constant. Okay, there's a lot of constants. Fourier's law constant, Fick's law constant, like that. Navier-Stokes constant, Euler's constant, like that. If you are full on that, sure. Okay, sure na. Console na kay ka. Okay, ganon. Okay, you get the point? Okay. It's gonna be maximize, ha? Okay, ayaw naman sa ura ko sa ka-constant. Ba yan? Kung ano dyan ang gisabu, ang acceleration due to gravity, mga density rin, anak ra. So, kuwang dyan na siya. Okay? Go farther. Okay? Like that. You get the point. Okay? Memorize sa diwa mga grabe, mga magnetic field strength, okay? Magnetic flux density, ganon. Kato ng mga Ørsted, mga Tesla, mga Gauss, mga Lumina unit of intensity, of candle, maganon siya. I-extend yun yung mga mga constants. Ayaw mo pag-depend sa mga handbook. Charot! Charot lang. Okay. Listen sa kunta na, no? Okay, but it's better to memorize a lot with siya. Okay? Because a lot to be memorization. Okay? Just like a doctor, a lot of memorization. Okay? Courses like that, too much memorization and application. Okay? In the laboratory. Something like okay, guys. So, muna siya itong buhaton. Okay. Nga, saan mo siya kang araw itong sa Sotero? Ako wala pa man sa kabawaan ni kay. Karoon pa man sa din ako ikuan, i-derive. You got the point? Pasad. Okay? So, ako yung tanawon kung ano dyan yung anime siya. Wow. Asa to? Masakit kong ulo, no? Grabe na kayo. Wow. Grabe ka kung tinud-on. Diba? Tinud-on, Jod. Okay. R. Diba kung mag-involve siya og cubic meter, masama na siya. Hala, oy, Sir Sotero, lisod biya kayo kay Jules, ito kagkalit sa cubic meter, mo ni siya karon. Okay? Oy, cubic meter, asa mo ni siya magamit sa Jules? Nabasa ha? Kaloka. So, we need to recall 1 joule is equal to tapos guys ha, atong ikuan para mapadung ra kita sa cubic meter ba. Our goal is to convert joules into cubic meter, but take note, this is not the same quantity. Joules is an energy and cubic meter is a volume. How can we correlate this one? And I don't know also on the spot. Really? Okay, so this is 1 joule. 1 joule, how many calorie? Let's start with 1 calorie, so it's easy, right? 1 calorie is equals to 4184 joules, right? Ganun. So we break down these joules into Newton meter first. Okay? Newton meter mole Kelvin. Now guys, okay, since naman tayo unit kato itong nakuha mo ni siya diri ari, imo sa ni siyang i-connect diri ari dayon ha. Surot, kay makatabang man ni siya itong unit nga nakuha, kay wala na itong involve ang harbon dayon na. Okay? So ganon. Now, okay, Newton is equals to kilogram meter per second squared. Newton is very useful. Always, all the time in the conversion factors in physics and in chemistry and in physical chemistry, thermodynamics and unit operations. Okay, so Newton is equals to kilogram meter second squared times meter cuba chuchu. Wala. Diba? Okay, ganan. And then over mole Kelvin. Diba guys, mo ni siya itong R. O niya, diri sa denominator na itong nabi natin R times T. Okay? Ang atong T, atong gayon na is Kelvin. So, i-multiply pa rin nato siyang Ki-Ari. So, Kelvin. So, wala siya. Atong i-cancel ang pareho. So, Kelvin. Okay? So, it's gonna be kilogram meter squared second squared over mole. Kakaloka. Okay? Ganon. Now guys, nakakuha naman tag kilogram meter squared second squared here. Kasi to, na kung itong inungot ang kalit. Okay. Uy, mo naman yung taas mo kayo. Dagan mo kayo nilubog. Kung anday niyo ba, dagan kayo nilubog. Diba? So, kilogram meter squared second squared. Yun naman sa kilogram meter squared dari ari. So, daog na. So, sa unin ako, i-multiply na ako, i-divide para makancel ni siya. Mapilin, mole na siya. Umuna na siya, molar flow rate or mole flux. Okay, mo naman siya nahabilin, ang mole. Oh, diba? Klaro kayo. Okay, so kilogram meter per second. So, sama na mo siya. So, of course, imo na siyang i-divide. So, kilogram meter squared second squared divides. Ang mabilin mo is a mole. Ganon. So, mole na siya. Muna na siya, molar flow rate and then over the second. Okay? Since, diri-ari guys, kinapamagin siya yung seconds ang good, ang diri-ari. Okay? You got the point? Muna siya nagtabo. Pero kung if we write also nga, imo yung pangitaon ng cubic meter in terms of joules, atong suwayan po. Okay? So, Newton meter. Okay, 8.314 specific gas constant joules over mole per Kelvin. Okay. Ganon. Then, Newton meter mole Kelvin. Right? Ganon. Newton meter is the unit of, energy, right? And this is force times distance. right? So force times distance is equals to work. Laoy, loka. Work is equals to force distance. Problema kayo. Charot! So we have pressure is equals to force times area, right? Pressure is equals to force times area. Nakakaloka. Diba? I-correlate mo ang work is equals to force times distance and pressure is equals to force times area. Now, in your equation, naba na siya aning mga quantities sa imong mga formulas. Naa siya ikuan, na siya area, nasa siya length nga meter. So, diri ari, mawala ang imong force, makancel nimo during ratio and proportion. So, ang mahabilin, pressure is equals to area and work is equals to distance. Ganon. Okay. Now, gusto man ka mulugwak ang cubic meter. Usahaw man ni aning gayuna. Cubic meter. Okay? Because we need to say, cubic meter, Pascal, right? Pascal, mol, Kelvin. Kaya naman tayo Pascal dito nga itong ipang substitute dito sa babaw. Diba? P2 minus P1 sa butak. So, Pascal sa niya siya sa pusin. Ingani siya nga R atong gamiton. Cubic meter, Pascal, mol, Kelvin. Kani siya. Diba? Atong tanawan kung 3.45 by June ni siya. Reverse atong gamiton. Okay, since we know that 8.345 joules man na siya. So, di ko makatugot ni Ana kay di ba na cubic meter. You get the point? So, I arrange ko sa cubic meter. So, I have the last option to use the ideal gas law equation. So, PV in RT using the standard temperature and condition. Okay? So, akong gipang correlate guys ha, ang formula sa work, ang formula sa pressure, okay, sa energy, until such time which is more closer to arrive to the most, relevant unit that we are trying to solve or to find out. Something like that. Okay, so it's gonna be like PV is equals to nRT. Okay, pressure. Oh my gosh! Tanawa ko niyo, hindi pinari pressure diri ari pero kani siya diri ari guys, lubog ra ni siya. Diri mo may nakapartan ng mga problem solving kini mga given nga not necessary to solve the problems. It's only the certain temperature para maka-obtain ka nga quantity. For example, like this. Conduit meter at 300 Kelvin and total pressure of 1 atmosphere. This is the conditions in which we can have pressure of 20 kilopascal and 5 kilopascal. And then we can have a diffusion coefficient of 5.04 times. More na siya in purpose. Our operating conditions that we have that values, but it can never use in our equation. But this can also confuse the students like this and examinees because this is also quantities, right? So, tintal ba yun ta? Okay? You got the point? Especially light temperature. Transfer ni. Kaya temperature ng 300 Kelvin. O, diba? So, mabuang ka kaya no? Wapan sa siya concentration. Nga, kalit ba yan ang examination? You got the point? Kalit ba? Kalit. So, you are not prepared to that kind of problem. And that's on the spot when you take the examination, right? It's not prepared. All you have to do is to study, maximize your study, but you don't know what to expect in the examination. So, kung ikaw, hinay ka paminsar, hindi ka kakakuha, di ba? Maglibog ka ba? Okay? And then, saan akong buhaton ni ini? Okay, magkaganan. Okay, so ang imong buhaton na, tanaw ni mo ang madili kinahanglan. Ano na siya ipugos? Okay, ipugos o so nga doon sa una. Ako rin gisulti akong style kay pugos yun ako pasok dito nya mangita jud ko equation nga para lang jud masud na siya di man na siyang ana di ayo ang masud ra jud sa formula imong ikuan dito ipasok ganon really okay so mo na siya natabo mo na siya ajud mo kalibog ani mga aning sahay ganon so 200 Kelvin total pressure as just an operating condition to have this kind of values. You got the point? Okay, kasagara matintal ra bag yun. Okay? So mo na niya tapo. So, ang atong universal gas constant guys, so it should be cubic meter, Pascal, mole Kelvin. Why we choose this? Because it's the same with liter, atmosphere, mole Kelvin, but we don't know the exact figure. We are just troubleshooting the unit to agree so that it will be cancelled somewhere along the way, something like that. Okay. Now the last option is to use the derivation of the gas constant by using the ideal gas law. Actually, guys, you can memorize a lot of universal gas constants. No need to derive, but it adds also, headache to your brain cells. Too much constants to memorize. Not only this, especially if you're taking chemical engineering, mabuang katak puti daghana. Okay, so you will use only two like this, as long as you can derive others. Okay, like that, like that. But it depends if the derivation is not too long. Because ideal gas law is manageable. It's not too long. What I mean, the other topics in major chemical engineering is very too long, so that you can arrive this. Oh my gosh, you can arrive this formula and you have to integrate, get the limits like that, ganon, chuva, chuchu. And then, maglibog kag samot niya, ang imong gikuha, ang formula pa. You get the point? Para lang imong gamiton. So, nagdagdag lang kasi imong time na maglibog kag samot. Mabiyaan to nimong ubang mga questions dito. Okay nga, medyo sensayon ra. Ana ba? Okay, so mo nang mag-memorize dagdaghan. But in my case, I memorized only at least 3 or 4 akong gi-memorize ani upat. Ang duha nakalimot ko kay pila na gusto ka tuig, 20 years plus. Okay, duha ra jud akong mapasok sa akong brain cells. Ang 0.08205 ug ang 8.314 joules mole Kelvin. And then this 0.08205 liter atmosphere mole Kelvin in terms man siya sa volume kay liter, yung pressure atmosphere. So ato siyang taparan ug ani sa na makancel sa diri sa atong mass flux equation. So it's gonna be cubic meter Pascal over mole Kelvin. So unsa man ning ana? So ari din ta sa ideal gas law equation. Nagbishlish na ko, guys. Sorry if you cannot understand Cebuano or Bisaya ha, because nakakaloka. Okay. So now, di ba mag-ano ka diri no? You will derive the R. Take note, you will derive the R here in the ideal gas constant. But don't use this 300 Kelvin. This one. Though you can use the 1 atmosphere, because 1 atmosphere is already a standard atmosphere. Okay, but never use the 300 Kelvin, that is superheated. You cannot use that one. Too much temperature. It's more above boiling point of water. 300 degrees Kelvin, I think so, right? 20, so minus 273. Ganon siya. 300 minus 273, pila siya. It's less than, mataas siya, di ba? Okay, basta, never mind. Muna ay na siya isod. Ang mo isod diri ari, guys, ang pressure nga 1 pressure kay Pascal man nato isulod, no? So ang standard na pressure sa in terms of Pascal pila man? Naputaan ni. So 101,325 Pascal is just equal to 1 atmosphere, right? And then it will be equal to 101.325 kilopascal is equals to 1 atmosphere. So use the 101,325 Pascal as a standard temperature para makuha na to ang units mo parallel dito sa ibang mga units. Okay, so 101,325 Pascal, okay, times, okay, the volume. Now the volume, guys, in ideal gas law, again, by Dalton's law of partial pressure. This is where your theory works. Theory, or memorization. In ideal gas law, okay, 1 mole of a gas will occupy 22.414 liter of a gas in a volume. Okay, at STP. So you memorize that at STP by Dalton's law of partial pressure and Dalton's law. Si Dalton ang nag-discover ni ini. Okay, so we have 22.414 and this is liter. Oh my goodness! We still have to convert this to cubic meter. Because this is liter. How can I convert liter per cubic? It's very easy, right? So, from 1,000 cubic centimeter, ganun siya. Ato na siya i-convert dito to the area, sa mukha na eh. So, 22.414, okay, liter. Then 1 liter is equals to 1,000 cubic centimeter. 100 centimeter is equals to 1 meter. Raised to the power 3. Ang ganon. So, muna na siya kung cubic meter. Oh my gosh, atong ibutang diri ari. Okay, guys. Nakakaloka. Okay, ganon siya. So, 100 raised to the power 3. Guys, pila man siya, guys? 100 raised to the power 3. 1 million ni siya ron. Klaro kaayo. Okay. 100, chararat. 100. Katuluon mo siya. Na 1 million. Okay, 1 million. 1,000. Okay, 1,000 times 22.414 divided by 1 million. Hoy. So this is 0.022 cubic meter. 0.022 cubic meter. Like that. Okay. Number of moles, of course, mole siya. And then capital R, in which you will find the R here. And then times the temperature here, guys, is 273 Kelvin. Take note. 273 Kelvin. Ay mong gamiton. Kung imong i-zero, di ma-zero imong values, that's why 0 plus 273 Kelvin. Because 0 Celsius at STP mo gina siya sa ideal gas law. Okay? Kilahit na ba itong mga enthalpy of formation, mga ganun-ganun. Kaya dito, ang imong standard baya ang 25 degrees Celsius. Here, 0 degrees Celsius. 1 atmosphere, ganun siya, and 22.414 liters of gas. Ganun. So, R is equals to 273. Okay, let's use 273.15. Actually, pwede rin siya 273, but to be more precise, use 273.15 kaya maugin siya ang exact value sa kuan, Kelvin. Okay, Celsius plus 273.15. Okay, use this one, 273.15, and then solve for the value of R. Let's see, guys, kung 83.45 ba dyan siya. Okay? Okay, Kuan man, ako man yung ituki, nga na siya. Okay, so, 273.15, my goodness, okay. 1 naman gyapon ang mole, guys, kay 1 mole man siya on basis of calculation. 1 mole of an ideal gas. Okay, so, 273.15, wala na siya atong denominator. So, 101,325 times 0.022 is equals to divided by 273.15. So the answer, guys, is 8.1609 cubic meter, Pascal, mole, Kelvin. More or less close lang siya, pero it's not the exact 8.3145. Maybe somewhere on the decimal point, right? Okay. So let's review again. Okay. 22.414 liter, it's gonna be 0.02214. Atong idaginot ang decimal point because, you know, close na siya sa 8.3145. Nanatay 8.1609. Okay? Basit sa mga, yan yung mga decimal places, na ito nag-carry, ito nag-appeal. Okay, so this is gonna be 0.02414, 0.02214. And here also, gonna chupa. Okay. So it's gonna be like this, 101,325 Pascal times 0.022414 is equal to, divided by 273.15 is equals to, yes! Tama! 8.3145, perfect. Okay, we should carry the decimal point because in using the volume, guys, I stopped only to the 0.022. I did not use the point something. Then if we try to put that out, our R will become 8.3145, the same siya. So 8.3145 joules per mole is just the same 8.3145 cubic meter Pascal over mole Kelvin. I need to investigate why it's the same number because it's already not the same unit. So use the ideal gas law to compute for the R because there's an R there in the PV and RT. But use the STP, standard temperature and pressure. Okay? Kaya wala naman kailangan choice. Wala dimension ang gas constant sa problem unless it is being specified there. Okay? Here. There's no gas constant here. But your formula have. So, problem. Okay? So, ato na siya balikon atong kuan equation. Ato na siya ipasok. Ang kanang 8.3145, sige, pasok na nato siya. Fairness. Kaloka. Asa naman to? Mo ni siya, guys. Chemical Engineering Board Examination, May 1994. Yung ano siya lisod. Murag lisod na siya no. Kaya mangita-ngita, manggod ka. Right? Di man siya diretso. Yung mag-analyze pa ka nga, mauna siya. Lah, ginoo ko. Murot mo sa imong oras. Di ba? Kalaw ka. Yes, only one is being asked, but so many, you have to think, oh, what's gonna happening like this? Then you have to correlate like this. No, nabuang na ko ang grabe ha gud sa kuan good 1994 luka kanito sa bugbog ani di man jud kay mo lisod kayo pero the way you are kuan ba mo think jud ka ba nga mauna unsa man ako ay mo di man siya mo qualify ganun ba di ba gusto biya tag nanadayon. Okay? That's a normal feeling na gusto sa nanadayon pero masolve dayon. Di ba? Nobody wants so many problems. Then how can we solve if you have so many problems? So, minimize the problems. Okay, but here too much. Okay, so negative DAB, alam mo siya. So, NA is equal to the diffusion coefficient of 5.04. Atong di-repeat by using the universal gas constant. Okay, so 5.04. So, very easy na guys, no? Mag-constant i-memorize nga pareha siya value. Ang kaning 8.31, duha na unit ang 8.314, it could be joules mole per kg. Pwede sa siya mo cubic meter pascal nga na siya, right? So, at least, there's an additional learning that there's another unit nga R in which dili na ta mag-derive in the future. O, diba? So, times 10 to the negative 4 m squared over second times the area chuba chuchu 0.025 times 0.050 okay times the pressure 20,000 okay my gosh okay 20,000 no it's not 5,000 sorry 5,000 minus 20,000 okay and then this is negative okay ganon because this is C2 minus C1, right? Okay, so over the length which is 2 meter times universal gas constant derived 8.3145 cubic meter, okay, cubic meter and then Pascal, okay, mole, Kelvin, and then times the temperature which is muna natin atong temperature yung diri guys, kanina siya yung temperature na 300 Kelvin atong gamit. Okay, dili naman siya kuan. Katong ideal gas. So kaning 300 Kelvin. Okay? 300 Kelvin. Okay. And then length which is ato ning suwayan guys sa kay ano mo asyo mo gutag kuan standard din na naman gud siya 300 Kelvin po dito sa iyang problem. Okay? So 2 meter. So magkasil-kasil na tayo. So Kelvin, ganon, chupa-chucho. And then okay, meter squared, second, meter squared, chararat. Okay, Newton meter squared, okay, ganon. Then cubic meter, Pascal, Newton meter squared, okay, mole, and meter. So it's gonna be, okay, makancel siya dali ari ang weight. So cubic, M4, S Newton meter squared, okay, over meter cube and meter squared, chararat, times mole, and so it's gonna be M4 S Newton meter squared. Grabe. So we have cubic meter, medyo matabang no, grabe. Okay, over mole. So cancel na siya guys. Wow, bongga! Okay, we have now mole per second. So this is the precise unit of molar flow rate. O diba? Kaya naman siya second times sa denominator. Mo ni siyang hitabo. So muna ni mong answer, yung sa tagsaon. Oh my gosh! Mole per second. Sa to. Kaya kung ano siya guys, molar flow rate, hindi siya mas flow rate ang pangita. Molar flux. Okay? Or molar diffusion rate. Okay, so this is gonna be 300 times 2 times 8.3145 is equals to, ganun siya chupa-chucho. So 4988.7, and then it's gonna be negative ni siya, di ba? So 5,000 minus 20,000 is equals to, okay, times 0.05 times 0.025 times 3.1416 is equals to times negative 5.04 exponent to the negative 4 is equal to, then therefore divided by 4988.7 is equal to, so we have 5.95 times 10 to the negative 6 mole per second. Okay, my gosh, exponential. 5.95 times 10 to the negative 6 mole per second. Let's check the answer here in the source. Okay. Yes, it's perfectly correct. 5.95 something lang siya. Pero at least 5.95 times negative, more good siya. Okay? 5.95 again. 5.9567 something pa siya. Okay, but here, ato lang giputol 5.95. Okay, like siguro na, no? Diba? As long as more good siya ba? Okay? So muna itong mole per second. Now, if there is an additional question here, what is the mass flux or the mass flow rate? Okay? Then, you take account the molecular weight of your carbon dioxide. Okay? And then you will divide that 1 kilogram per mole. Cancel, and you have the kilogram per second, which is your mass flux or the mass flow rate. If the problem will still ask the mass flow rate. Here, what is being asked is molar bayat siya. Molar flow rate. Okay? Now, if there's an additional question also, what is the density of CO2 when it passes in the conduit? Ganun. So, how can you compute that one? Again, use the ideal gas law. PV in RT, then V is equals to the mass over density. And then since you know the mass flow rate, you convert that already, right? Using the molecular weight. Right, like that, and then the number of moles, of course, ideal, that is 1, R, nakakati, bingo, you can solve also for the density. Additional question, wala siya giingon dere, pero if additional questions will be added, then you can also get. Okay, you got the point. Okay, so parang ganun siya, i-reduce yung i-correlate. Okay guys, nakuha gina to ang 5.95 times 10 to the negative 6 mole per second. This is the molar flow rate. Oh my gosh. Grabe. Okay. Okay, my question is, does this question very easy for those examinees in that particular era talaga, in for chemical engineering board examination? Did they get this correctly? Because I feel this is not easy, really. This one. Mass transfer through diffusion. Okay, something like equimolar counter diffusion, mass transfer. Okay, so this is an example of membrane separation processes. I think so, huh? Like this, because that is also separation processes. There's a lot, right? I mentioned a while ago the distillation, the extraction, the absorption, the adsorption, like that, the crystallization, the filtration, the centrifugation, sedimentation, flotation, leaching, drying, evaporation. There's a lot, right? Physical and chemical separation processes. Okay. We have also the flocculation, right? Grabe naman. Flocculation. I think have also. Okay. A lot of mga shun. Okay. Nagigla siya permis sa physical and chemical separation processes. Okay? Especially in producing products. Ang common dyan ang mga crystallization, extraction, drying, sa last stage in producing a product. Okay? Na mo produce yung mga crystals like sugar. Okay? Sugar cane. Undergo na siya of mga drying, crystallization, evaporation, mga ganun siya. Okay? And sa petroleum, it involves also fractional distillation. Petroleum from crude oil as a raw material. Okay? So, ganon. Involve mo siya mga physical chemical separation process, catalytic cracking, thermal cracking, ganon siya. Pyrolysis at higher temperature. Okay, ganon. also have synthesis, I think so. Polymerization. Okay, polymerization and synthesis, right? Sa organic chemistry, because these crude oil are hydrocarbons, right? So more or less there's a polymerization reaction there and synthesis. Katong mga mga esterification, di ba? Katong mga etherification, carboxylication. Carboxyl ba? Carboxyl, C-E-R-B-O-C-I-L, carboxylicate, nasa sa organic chemistry na, mo-produce yung mga carbon, i-breakdown niya, balik, okay, carboxylic group, carboxyl group, okay, carboxyl nga na siya, carbon ba, C-O-O-H, may ganun siya, chupa-chuchu, okay, naman siya amino group, right, NH2, nasa tayo carboxyl group, ganon, i-break na mo siya, ganon, through the chemical bonding. O, diba? Chemical bonding, more or less mga kuha. Ano ito mga banding-banding po? Mga non-polar covalent band, ganon, mga van der Waals band, hydrogen-hydrogen bonding, hydrogen to hydrogen bonding, dipole-dipole bonding, okay, mga ganon, diba? Sa chemistry. Magamit ito tanan sa kuan, sa petroleum. Okay, bukon man mo ang kuan, ang raw material. So, Dagan mga buak dito. Okay, mo produce yung mga residues, mga byproducts, chupa-chuchu, combustion process nasa dito. Produce siya ng carbon dioxide and water, and then produce siya mga asphalt, bituminous product, or the bitumen, the black one, B-I-T-U-M-I-N, used in asphalting the road. Okay, that's also the product of, byproduct of crude oil refining in the petroleum industry. So meaning to say the wastes in the petroleum industry are all usable and have costs. Okay, so walang tapon. They will buy, except for the gaseous that will be released in the atmosphere. Exhaust gases, di ba? Mga killer gases, mga ano siya, let's say, magnesium oxide, mga ganon. Okay, so makadaot, cupric oxide, mga ganon siya, di ba? Alat. Okay? Release to the atmosphere. Problem. Okay? So, marami siya, guys. So, thank you so much for watching this live streaming. It took me 2 hours and 2 minutes for this. Only one problem. Oh my gosh. If you like this video, you can comment down below in the comment section, and then you can subscribe to the channel if you want. And then you can click also the notification bell for some newest updates of I Am a Singer, Eternal Voice. Bye-bye. God bless everybody. Now, I'll be introducing another problem which is more easier compared to this. Okay? Because this is tasky, okay, and then it needs you to analyze, you know what I mean, okay, but I'll add another problem which is more easy than this, okay? Thank you so much for watching, bye bye, God bless everybody, okay, kalas.